Hello, everybody. Welcome to Upstate Carolina Linux Users Group. We've started the recording, so that's why I'm speaking out loud and in a kind of a presentational voice. I'm on camera. How about that? Welcome, everybody, tonight. We're going to have a wonderful talk tonight about getting started with Linux by Barry Jones. Barry Jones is Brightball. And you do fractional CTO stuff, right? And you also run the Carolina Code Conference and the Carolina Code Conference podcast, which
Carolina Code Cast.
I apologize. Which is not affiliated with Carolina Code School.
Correct. Also cleverly named.
But anyway, we're glad everyone could come tonight, and good to see everyone here. And grab a drink if you haven't gotten one. And I'll let you take it away, Barry.
All right. Hey, everybody. So, I'm going to show of hands in the room real quick, just so I put out a poll on Jitsi to find out if you are new to Linux or if you've been doing this for a while. Quick show of hands. Who in here is new to Linux?
Hello? Okay.
T2 instance or something like that. And I just went through and I started following all these various tutorials about how to set things up, how to do how to set up like a PHP website and make it secure and everything. And then I actually put up my own personal website there. And I just managed it, and I just kind of kept working on it as a hobby in the background. And then after about a year and a half, people thought I was qualified for Linux jobs. So went with that, and it's really just been I've never been formally trained. I've just sort of always learned it as I go, and I'm a firm believer that just about anybody can just kind of dive in and learn it as you go. And so as Jay said, yes, I am a fractional CTO consultant. I didn't used to call myself that, but what I previously used to call myself, nobody knew what it meant, and apparently fractional CTOing is a thing that people will hire you for. So that's what I do now. I'm also the current organizer of the Carolina Code Conference. We have an open call for papers or call for speakers and an open call for sponsors going right now. If you want to go check out carolina.codes, love to hear more about that. Do a podcast called the Carolina Code Cast for the conference, and we're putting on episodes. We have a very special Valentine's episode coming out tomorrow where I'm interviewing my wife. So that should be a lot of fun. She is also a business owner, so we're interviewing her about kind of the startup journey of creating her therapy practice.
Awesome.
And I also teach GitLab instructional classes with C Quality. But let's talk about Linux. So I asked ChatGPT to generate a graphic of Linux distributions, and that's just what it came up with. It's kind of cool. And you might look at something like that and go, where do you even start with all this? And so we're gonna start at the very beginning here. What is Linux? Linux is a free open source operating system that has existed since the 90s. For any Gen Z people here, that's the late 1900s. Apparently that's a thing people just say now to make us feel old. But yes. It is one of the most popular operating systems on the planet, probably the most popular operating system on the planet. But it runs servers, desktops, laptops, Android devices, embedded devices. It's extremely secure and reliable. So what is a Linux distribution or distro? A distro is an operating system that includes the Linux kernel and often a package management system. Straight from Linux.com, the kernel is the one piece of the whole that is actually called Linux. The kernel is the core of the system that manages the CPU, memory, and peripheral devices. The kernel is the lowest level of the OS. Straight from Linux.com. So there are a lot of different distributions out there. Some you've probably heard of: Ubuntu, Red Hat, Fedora, Pop! OS, Arch, Manjaro, SUSE. There's a
Hannah Montana.
yeah, okay, that's probably up there somewhere. Super Gamer is one. Kate OS, because Kate, Bill X, some people name them after whatever. Stackintosh.
List didn't make the list.
Yeah, this is just whatever Google spit out in the search results when I hit show more. But there's a lot of distributions out there. And again, if you're looking at that and you're new to Linux, you're probably wondering, which one do I choose?
Which one do we choose?
We're getting to that. There is a correct answer. Not really. There's not really a correct answer. Just to avoid upsetting anybody in the room, there is not a correct answer. It's whichever one you like. But there's a lot of people that make distributions. There's a lot of options. You can find something that kind of feels comfortable for you. Under the hood, for the most part, they all do kind of the same thing. And so they all have the same core parts. And so the core parts of Linux, and we're not going to be talking about every one of these in depth by any means, but you've got a bootloader that starts the computer. You've got the kernel, which we already talked about, to manage the CPU and memory. The init system starts up everything. You have daemon processes that run in the background, as far as the background services that will run things like your sound and your printer and all that stuff. You have a graphical server that puts out the graphics to your computer, to your monitor. You have a desktop environment, and there's lots of different desktop environments because people like different things. Yay, variety. And you have applications, the programs that run on your system. You don't need to know all about that. I'm not going to quiz you afterwards, but that's essentially the core parts of Linux itself. This is just a bunch of screenshots of Ubuntu desktop environments from the Ubuntu website. There's lots of different desktop environments, and you can download Ubuntu with any of them pre-configured and installed. These go from GNOME, Unity, KDE, LXQT, Budgie, Cinnamon, Mate. There's a Studio version that is pre-configured for AV applications and production work. There are security versions that are very specialized to security applications like Kali Linux. There are other fun things on here like Elementary OS that's made to look more like a Mac to kind of give you a more coherent experience. I'm doing this presentation on a System 76 laptop, and System 76 is a company that ships computers with Linux pre-installed and offers support for them as well. And they also do their own Ubuntu-ish version of an operating system called Pop! OS. That's a lot of fun. But there's a whole lot of options out there. But for this, we're going to really focus on kind of what they have in common. And so, in common, they all boot up, you log in, and then you do stuff. It's not that complicated. It's not scary. You're either connecting to something remotely and you log in and you have access to a terminal, or you boot up the computer, you get a login screen, you log in, and you do stuff. Don't overthink it. It's not scary. So, despite all the very, very shiny little bits and pieces that are out there, from desktop environments and things you can customize and bend to your will to do what you need, most people who are running Linux, I'm going to go just quick show of hands if this is right. Most of us really just care about the command line, right? Yes? Yes. And
Yeah, I'll say it.
and the browser. Command line in the browser, and you're good to go. And so, when you get into the terminal, what exactly is so magical about the terminal? Well, it's where the files are. And in Unix and Linux, the philosophy is everything is a file. And that's really critical. Because everything is a file, you can do pretty much everything from the command line in Linux. Read, write, execute, get information, start stuff, stop stuff, kill stuff, move around, reconfigure. Everything you need to do on a Linux machine, you can do from a command line, which is great if you need to access one remotely because you don't have to worry about having some fancy environment to get to it or anything like that. It's very clean. It's all text-based. And, as you might have guessed, yes, there are lots of shell environments too, because people can customize everything, and they do. And there's built-in ones. There's versions where you can do lots of little variations and split ups and windows, and you can pre-configure your favorite environment. There's options that will give you different types of auto completions and information in the terminal about what's going on in your system. You can have it where it shows you the weather right next to where you're typing to see what's in your directory, if you want to do that. There's also other ones that don't require as much configuration, like Fish, that have a bunch of kind of pre-configured options that it feels like are a lot of best practices. It's not as configurable though. But you can do all sorts of other things, like you can use what's called the pipe operator. And so with the pipe operator, you can send the output of one command to another command as input, and you can chain these things together. So the pipe operator example here, I've done a simple echo command and said echo, my name is Bob, and it prints on the line below, my name is Bob. And then I echoed my name is Bob, and I piped it to the grep command looking for Tim. Grep is just a simple command that just searches for text in whatever text that's provided. And so it's taking the output that my name is Bob, and you see it doesn't output anything below it because it couldn't find Tim in there. Simple enough. And so on the last one I did, echo my name is Bob and grep Bob, and you can see that it output the line because it found it, and it highlights exactly where it found Bob. You can do that on text files or anything else. The pipe command sent the output of that echo command to the grep command. Write and append operators. You can overwrite and append file. So if I do that same echo, my name is Bob, I can do a single arrow and it will write it to a file called bob.txt. If I use the cat command, which outputs the contents of a file, it'll print out the contents of the file, and you can see that what the command echoed out ended up in that file. If I do a double arrow, it will do an append. So the single arrow will write the entire file from scratch. So if there was something in it already, it would have overwritten it. If I'm using the append command, the double arrow, it will add it to it as the last line on the file. So when I do my name is also Bob with the double arrow, you can see now that the file contains both. You can also output the entire file, the head or the tail. The head command or the tail command, head will output from the beginning of the file for the first 10 lines unless you specify a specific line count. And so for this example, I've specified one line just so you can see it was the top line. Tail, same thing. So it's just outputting the last line that was put in the file. And then the cat command again, so you can see the contents of the entire file. And you combine all of these operations together. So tail has an option where you can tell it to listen for changes to that file. And so we're doing the tail-f on the bob.txt file right there. And I'm piping the output of that tail call, that live tail call, to the grep command looking for Tim. And so here you can actually see, that. So you can see there's no output over here. But when we come over here, we're going to go through and we're going to echo several commands. And we're going to append them to that file. So first we echoed, my name is Tom, Ray, Jim, Phil, Tim, capital Tim, and then lowercase Tim over here. Now we've echoed all of those out while it's listening to this file. The moment that my name is Tim with the matching lowercase Tim comes out, it outputs it there, which is a very handy thing to do if you're ever trying to monitor live log files that might be coming out. If you're listening, if you're watching log files on a web server that's got active traffic, and of course there's too much noise because there's so much traffic that's going through, you might do a tail-f on the log file and then grep for, whatever keywords you might be looking for in your log, so that you can find out what's going on in the live server while you're figuring it out. Or it could just be something on your system. But it's very powerful to be able to, and you can pipe the output of those two commands to something else as well. And so you could even have another command that was after the grep Tim, and if it found matching output, then it would send that to the next thing, and so on and so forth. You can send work to the background with the ampersand operator. So we did an echo, my name is Bob. I don't know why that's the phrase I just picked for this, but we're going to build a lot of my name is Bob's here. I'm sorry. But so you've got the ampersand here. And so what that does is it sends that command, echo, my name is Bob, to be run in the background. And so it would immediately give me back my command prompt while that runs in the background. Now that finishes almost immediately, so we don't really have to worry about it here. But what you see there is that first line right here, this 159685. What that's doing is it's telling me that it sent the command to the background, and this is the ID number of the process. Then it prints the output, and then I get a notification that process 59685 is now done, and that was the command that started it. So you can see, so you can end up seeing that it sent it to the background, it told me a way to track whatever it sent, and then it reported to me back to me when it was done. Now, every running process in a Linux system has an ID. I mostly took a picture of this because I have a really beefy home computer, and I wanted to show you all the 23 processors. But this is a simple command line program called HTOP that you can install from just about any package manager. And what HTOP does is it gives you like a live running graphical interface to what's going on in your system. And I'm not going to spend a lot of time talking about HTOP, but you've got your processors up here, you've got your memory, you've got your swap space, you've got your load time, tasks that are running, and you can sort and filter and go through these things that are over here. But those process IDs, you can see the process ID of each thing that's running over here with the ID number that's there. And this is, around in those 50,000s. You can see the user that ran it. And so if it was the root user, if it was the my user, I can see them right here. You can see the priority right here. The priority of all these is 20. Now, priority is something that it's managing behind the scenes, but priority is, by default, it's 20. And if you wanted to run a bunch of different commands at the same time, and you wanted certain ones to be responded to more quickly by the processor, or you need to run something for a long time that wasn't that important, you can adjust the priority of the command so that it is lower in the priority tree for the resources of your computer. And so if you need to run something in the background for a really long time, but it's not that important, you can set the priority really low. And if the resources are needed by something else, it'll just kind of pause, which is really, really helpful. And granted, these days, there's a lot of other ways that are abstracted around, not keeping you from having to worry about that type of stuff. But if you happen to be running all that stuff on a system, it's good to know it's there.
I have a quick question.
Sure.
You taking questions?
Oh, go ahead.
So I use HTOP, but I've never seen that process, the tree view. What did
Yep.
you do to do that?
I think it's one of the options. It might be the list option. This was I think it's F5. I think it's the list option. It's set up for the default of my system, so this is actually just how it came up whenever I started it. I don't remember how to get into there, but I know it's in there. I know there is a list and tree option for you to flip through. But with that process ID, you can, even if you're not in a program like HTOP, you can look up the process, you can find out what it's doing, you can find out how many resources it's using, processor power, you can find out who started it, what the original command was that ran it, and so on and so forth. And you can also kill it. There's a kill command. So from the command line, you can type kill on the process name and various different creative ways to kill the process, if need be, to end it. You can do all those from your command line. So if you were to remotely access a system and something was running that needed to be, you could just type kill, whatever the process ID was, and that thing would go away, and you could restart it if you needed to. So we said everything was a file. So what about files? So I've just concocted a very simple little example here of creating a directory, moving into the directory, CD change directory into the directory, touch to create a sample file, and touch because I can't think straight today for whatever reason. Touch made me think You've Got the Touch Transformers movie. So the next example is echoing You Got the Touch to an Optimus Prime file because that's how my brain works sometimes.
And now that song's going in my head for the rest of the week.
Indeed. And you've got the power. So, but the last command that we done on here is a command called ls. It just lists the contents of a directory. And so we can see now we've got the dot and dot dot. It's just dot is the current directory, dot dot is the directory one tier up. And then you've got the files that are listed over here. You've got Optimus Prime text, sample file text, and then on from left to right you've got permissions, you've got the user, the group, and a good bit of information that's in there. So let's look a little bit closer at that. And so just to demonstrate the pipe command, I just reran the ls command, piped the output to a grep, just so that we could look for just the Optimus file, and you just get the one line that matched Optimus. So you can, again, just demonstrating the usage of pipes to run any command through just about any other command and filter and work with it. But you've got file permissions, user and group ownership, last modified time, file name. Here's a better graphical breakdown that I got from linuxhandbook.com. And so this shows you the file type. It's either just a file, or this will be a D if it's a directory. Then you actually have the permissions, which we're going to talk more about in a minute. Hard link count, user or owner, group owner, or user owner and group owner, the file size in bytes, modification timestamp, and finally the actual file name. I don't know why they chose Agatha for their example, but I'm sure there was a reason all along. And before I go down too much extra, if you're curious about how I knew the options for the ls command, there's something in the Linux command line called man pages. Man pages are a really helpful way to find out about just about anything. And so you type man in the command name, and you will get a giant guidebook of everything about this command. What its arguments are, its description, synopsis. You can scroll down this. You can find out every single option that's in there, a lot of times with examples. Man pages are great, and they're only a man and whatever the command happens to be at any time. So back to file permissions. So everything being a file in Linux means that everything also needs permissions. So we talked about this being a very secure operating system. And so one of the things that you get to do in a Linux environment is you can create users. Users can be a member of groups, and you can also assign global permissions that are just for everybody, whether they're in the group or not. And so every file or directory is owned by both a user and a group. So typically, you will end up creating a group that has permissions on some type of shared asset, and you will add users to that group with whatever the permissions are, so you don't have to go and hand them out individually to a bunch of individual people. You can also create specialized users. You can create users that can't actually log into the system. You can create users just for running certain processes and programs. Your web servers will probably have their own user, for example, and you may want to restrict these permissions for what these users and groups can and can't do, what they can and can't access, and it makes it really easy to do that in a pretty straightforward way. But the permissions come down to three basic rules: read, write, and execute, R, W, and X in this little graphic right here. The first ones on the left are the permissions for the user. In the middle is the group, and on the right is the permissions for other, just anybody in general. And so in this particular example, the user can read, write, and execute. The group can read and write, and everybody else can just read the file. Also from linuxhandbook.com. And so just some examples: whenever you need to change the permissions of one of these files or a directory, use a command called chmod. And chmod, you can use numbers to represent these. And so the numbers are set up in a pretty straightforward way. Read permission is 4, write permission is 2, execute permission is 1, and no permission is 0. And the reason that it went 0, 1, 2, 4 instead of 0, 1, 2, 3 is so that you can add these up to combine them into a single command. And I've got a chart of those on the right, or I've got kind of a list of those on the right side over here. So 0 is, of course, nothing. 1, we said execute is 1, pretty straightforward. 2 is write, but 3 is what you get when you add 2 and 1 together. So that's that's write and execute. Then you've got read is 4. Then 5 is what you get when you add 4 and 1 together. So that is read and execute. 6 is read and write. And 7 is all the above, read, write, and execute. So full permissions on the file would be 7 for whatever group you're talking about. And so whenever you are adding these permissions onto the system, you would end up entering, and you would type chmod and then a number for each unit in the group. So you would end up doing, the first number reflects the user permissions, second number reflects the group permissions, and the third number reflects the other permissions. And so we've done just as an example, a chmod 475 Optimus Prime right here. And then we're doing an ls, and you can see that we've changed our permissions now to read, write, execute, and read, execute. Now, there are shortcuts to this. You don't always have to just do the numbers. You can do these simple little plus and minus X, R, and W. And so if I do a chmod -x on Optimus Prime, it will take away the execute permissions. If I do a chmod +w, it will add write permissions. And if I do a chmod g, that means group +x, it will add execute permissions for the group. Just some simple examples right there. And so if we're talking about an execute example, I'm not actually going to demonstrate this, but if you were to just create a file, call it demo.sh, add in a couple lines that can be executed, and then add execute permissions to it, then you can type the name of the command and it will run once executing is there. This is a simple little demo hello world file, and the first line in the file is this little comment string at the top. What that does is it tells it what should be executing this code. And so whenever you run echo, if you're at a bash terminal, it would actually access bash. It would pass this command into bash. It would have bash runs. And so what we're doing there is it's telling bash run echo hello world. And so in the previous line up here, when we ran the command with the little /, just output the hello world via bash. But because you can just specify that at the top, you can set it to anything. You can have Python run something, you can have Ruby run something, you can have anything that's available on the system. It can actually execute the simple binary, or the simple script. But as we said, all files and directories use permissions, which allows a whole lot of fine-grained control. Now, next up, you got package managers. So to give a quick example of the breakdown that's in here, we talked about a distribution generally having the Linux kernel and a package manager. Package managers are how you install your applications or packages. They get those applications or packages from repositories. There are some that are built in. You can add others, though. People publish. There are lots and lots and lots of repositories that are published. Some for very specific single packages, some for entire replacements of everything that's on your system. And there's also dependencies. The way these all come together is you would use a package manager to install a package from a repository along with any dependencies that might be needed on your system. One of the cool things about Linux is that rather than pulling down an application that might need something that every other application on your system needs and it bringing its own copy of it along with it, a lot of times it'll end up using a shared library that's available to lots of other libraries on your system, and it will just specify the dependency. Linux will download it one time, and all of the packages that use it will use this one central dependency. So as a simple example here, this is the apt install MySQL server command, and it gives you a list of all of the additional packages that will be installed. It gives you some options for suggested packages, and as well as the various new packages that will happen. It gives you the option to hit yes or no and exactly what the size of all of these dependencies will be. I did not want to actually install MySQL server, so I hit abort. No surprise, there are lots of different package managers. You've got apps, which we just saw, DNF, Yum, Zypper, Pacman, Portage. For the most part, they all work the same. I don't want to get into any little holy wars about what may or may not be different about them or which thing you might prefer. But there are a lot of different options that are out there. They all do pretty much the same thing. If you're using any type of tool to automate installing stuff like an Ansible or something like that, they'll have abstractions that will just let you say, I need this package, use whatever package manager's on the system, or you can specify the specific things we need to. But, if you wanted to connect remotely to a server over SSH, you'd connect remotely and you would get a terminal. So this is me just connecting to another server at my house. And so I logged in, I got a terminal, and I can do everything from there just like I was on my own terminal right here. If I needed to, I could connect to that machine at my house from right here as well. I could do just about anything that I would do in front of it right there. Ultimately, I strongly, strongly, strongly recommend learning by doing if you're getting into Linux. All this stuff breaks down into, you log in, you do stuff, you get to the terminal, you move around, you create files, you run things, you copy things, you move things, you adjust permissions if you need to. You start things, you stop things, you see what's running. It's pretty straightforward stuff. It seems scary. It's not. It really just takes a level of comfort from practicing. And so the thing that I would recommend more than anything that I mentioned when I first started here is just go start doing a tutorial. I mean, there's a free Intro to Linux course that's on linuxfoundation.org, which I've linked right here. It's a completely free 60-hour course if you want to do that. That'll take you through a lot, give you a lot of hands-on labs and everything to get more comfortable with it. But I mean, like I said, the way that I learned, there was a hosting company called SliceHost that I used that was they were acquired by Rackspace. They were acquired by Rackspace years ago, and they were the basis for the Rackspace cloud environment. SliceHost was a great host, and one of the things that I liked so much about them is that they had all of these user-made guides and tutorials for different aspects of what you might want to do. If you wanted to install a PHP server running on Apache with MySQL behind it and get it secured and everything, they would guide you through all of that. DigitalOcean has been around for a while, and they are really the closest thing to what SliceHost was. They've got lots of wonderful guides on their website for just about anything that you could want to do. If you've got a favorite programming language or something like that, I would highly recommend going through some of these tutorials and just learning how to configure a server. Just go through it, step through it. They explain everything. You can turn on one of their smaller instances for like $5 a month. It's really, really easy and cheap to just set it up. You'll be able to connect directly to it over SSH. And then once you get in there, you can go through, you can start installing stuff, you can configure stuff. They'll teach you how to secure it. When you have to secure it, they'll teach you why you need to secure things this way, how to open access to the firewall and everything. And just maintain it. Set up a website on it. Try something. Do a project rather than relying on an outside web host. Do it yourself. It seems scary because you haven't done it before, but it's not that hard. And Linux is really reliable. It's not going to go down easy unless you're running a database that randomly uses up extra bits of memory and decides to just kill things randomly for no apparent reason. Looking at you, MySQL. And that happens. But Linode is another good option. If you want to set up a PHP site or a Ruby site or a Python site or whatever else like that, or you just want to get on there and do some experimenting, there's lots of things that you can try out. If you want to try it out on your desktop, VirtualBox is a free virtualization system. You can install any complete operating system into that you want to, pop it up in a window and run it within your computer. You can also create these wonderful bootable USB drives. And so if you just have a little USB stick handy, just about any distribution that's out there will have instructions to do this. You plug the USB stick into your computer, and it will show you how to take the copy of the operating system that you just downloaded, install it on the bootable USB, restart your computer, and tell your computer to start up from the USB drive that you just installed. And you can actually try out whatever distribution of Linux that you've got on your computer right there at home. And if you want to install it, you can install it from there. If you didn't want to install it, you could just shut down, unplug it, and then you get your computer back just how it was before. But it's really easy. There's a lot of options. There are very specialized options that are out there. I know some people who have even gotten into carrying around a specialized USB drive with them that has extra storage space on it, so they can just plug it into whatever computer they happen to be at, pull their computer up, save everything back out to the USB, and then move on. And you can get really, really, really clever with this stuff. But it's fun. There's a lot of options to experiment with. It's really easy to get into, but the best possible thing to do, just try. That's it. Any questions?
Couldn't help but noticing your terminal is not the default one that you might get from Ubuntu or something.
You did notice that. Yeah. Another way you can try out Linux is with the Windows subsystem for Linux, because I got an Alienware computer that had all those processors. And so I was running the Windows subsystem for Linux when I was putting this presentation together, because it was easier than doing the screenshots on my actual Linux computer. But everything's pretty much the same.
But like that gem thing, that's like aftermarket, right?
Yeah, that was actually ZSH, my ZSH shell, and so it's there's a theme in my ZSH that will, and you can configure it. So if you move into a directory that has Ruby configured with ASDF, it'll tell you what version of Ruby was running, and it'll have a little gem there. If you move into an Elixir directory, it'll show you a little droplet in the version of Elixir that's running. It's all sorts of fun things you can do with your shells. OMyZSH is a really good open source one that's out there. They've got instructions on exactly what you need to do to set it up to pull things in, and it's very configurable. There's lots of plugins. You can tweak it and play with it and have a lot of fun. Had to make me point out that I did not own a Windows computer. I am ashamed of this. The first Windows computer I've owned in 20 years. Good.
Difficulty in peripherals.
So Linux is really good at peripherals these days. I ran Linux exclusively from 2015 until about 6 months ago. And the only reason that I stopped doing it 6 months ago was that I was trying to get too much juice out of one really small Linux box. So I've got, if you go to the System 76 website, they've got this little cube looking thing called a Meerkat. And it's it's literally like this big by maybe 2.5 inches tall. And it's got all sorts of ports and everything. But there is a power limit on those ports. And I was trying to plug too much stuff into it. And it was causing and having 3 monitors hooked up and this little in this little box with camera and microphone and everything else, hooked up to a hub that was hooked up to a bunch of other stuff with external hard drives and everything too. It did not cooperate that way, and so that was one of the factors in me getting the Windows machine. But up until I tried to plug way too many things into that one box, it was great. I mean, I had multiple monitors plugged in. Everything worked pretty much just out of the box. And I tried Linux off and on for every other year for like a decade, because I moved from a Mac to Windows full time. I went from Windows to Mac for 10 years, and then I switched from Mac to Linux because I wanted more control over my machines. And the peripherals and the ease of use was one of the biggest things that I cared about, because it was nice knowing that I could customize every little detail of there, but I didn't really want to invest the time in it. I wanted just good defaults. And so I ended up, I actually tried a bunch of different distributions. I ran Fedora for like a year. I ran Ubuntu for like a year. I'm currently on Pop! OS, and I'm pretty happy with it. That's the one that System 76 ships with, but I've also installed it on some other ones. But it's, a lot of people really seem to like Arch. I've never gotten into it, but Arch is also a really good one if you want to get into it. I've heard the documentation of Arch is wonderful. Everybody says good things about that.
Do you have a favorite?
Do I have a favorite? Right now, Pop is my favorite. I'm a big fan of what Pop's doing, and they're working on a pretty major UI update that is either going to be really good or it's going to tank the entire company. So. But they keep teasing that it's great, and so there's a lot of stuff to look at on the website.
What flavor is Pop?
It's an Ubuntu flavor. It's basically just a shell over it that has like a windowing manager and some UI niceties.
Basically, GNOME desktop.
Yes.
In the chat, someone was saying that my Z shell was kind of buggy in WSL. It's working for you though.
Oh, that was me. Do you guys hear me?
Yeah.
Hey, John, go ahead.
Oh, yeah. I had quite a dilemma. I'm also on the Nashville forum, and I had a bunch of Linux guys who are more gurus than me. I'm no guru. I know how to use it, but they fought with me, and so what happens is when the paths get really, really long, like I could show you just an example of I could put it into the chat here. Will not work on OZ shell, but works fine with Bash. But so something like this does not work on the Ubuntu WSL. I tried several different, scripts, and I literally had one that just use the basic setup. I even removed, any kind of. I think it's a Z shell in general. But if somebody has a way of getting it to work, I'd love to know. I like
Well, no, so that is true. There are a lot of quirks with WSL. I thought that it was going to be just great and seamless and everything, but it's not. There are a lot of weird quirks to it that you have to work around, like some of them revolve around SSH. It's not. It is more pleasant than navigating around PowerShell, but truth of the matter is that the way that I have everything set up at my house now, I've still got my 3 monitors set up. I've got the Alienware computer on my left 2 monitors, and then I've still got that little Linux box sitting next to my keyboard, hooked up to the vertical monitor on the side. I've got it set up to use an Ethernet-based KVM switch, which
Barrier.
barrier. So I can just drag my mouse off the right side of the screen, and it goes right onto the Linux desktop, and I can just command it from there. And then whenever I actually need to do any programming work, I actually do that all on the Linux machine. So I don't spend a ton of time in WSL. I spend so much time in meetings these days that's the primary driver of what I've got with Windows. Plus, I'm doing a lot of the podcast stuff now. And for some of that, if I needed to deal with any support from any of the various companies that are out there that provide these tools and services, that was a little bit of a smoother experience with the Windows stuff. But any real work that I need to do, I do on that. And so if you've ever used VS Code, VS Code has a really, really interesting setup to let you work remotely, whether it's over SSH to another server or something like that. And so what you can do with VS Code is you can tell it to open up a directory over SSH. And when you open the VS Code system, I can open the window on Windows. Everything I'm doing is actually on the Linux machine right next to it. If I open a terminal, the terminal is next to it. If I start the application and run it, it automatically manages the port forwarding and everything of whatever I just started, and I can open it in a window on the Windows computer that's right there. I'm still doing all the development on that Linux computer. And so don't think that I'm selling WSL by any stretch. I don't rely on it by any means. I go straight back to the real Linux computer. And there is a part of me that is desperately wanting to just install Linux on that Alienware machine, but I don't have time to deal with if it doesn't work like I want it to just yet. So we'll get there.
I highly respect your setup. I'm a .NET developer. I've been married to Windows for years. I used to program the Windows kernel, but now I want to get out of Windows and never see it again. So I hope I can get a Linux and maybe Mac set up.
Well, about 5, 7, 8. Gosh, I'm old now. Well, 8 years ago, I guess it was, I actually tried to get into C#. I liked the C# language, but what I hated was moving into a Windows environment. I lost all of my Linux tools and Unix tools that I'm used to, because when you're doing development in Ruby or Python or PHP, if you need something from one of those other languages while you're using a different language, you can just run a command line and get right to it.
.NET Core works great on Linux.
Really?
Yes,
It
fantastic.
Okay.
I was just about to, you beat me to it, .NET Core, especially with JetBrains now. They have Rider, which is fully Linux. I think you can run on Linux.
Nice.
It's actually better than Visual Studio. I'm going to hope to get out of Visual Studio if I keep pursuing software engineering.
Yeah.
Doing
Not to drop too hard of a hint here, but that sounds like it would be a great talk at a particular programming conference that I know about,
Or user group.
or user group. Yes.
I'd love to attend it or be part of it.
I'm going to talk for that, please. That'd be great. I'd love to hear more about .NET Core on Linux. We need more .NET talks at the conference. I have not gotten a lot of those submitted, so please, seriously, that'd be a really cool thing to do. Other questions?
Yeah. So Barry, you mentioned about pipelines and Unix and Linux.
Yeah.
And so this isn't a question. This is a story about how Douglas McElroy and Donald Knuth two famous computer scientists had a challenge to write a literate program that would find the most popular words in a say a 20-page technical paper, and then print them out, by the order of most popular. And Donald Knuth came up with this very complicated low-level program that was pretty long, and then 6 lines of Unix, and I'll post those in the chat here.
Nice.
That's it right there.
Wow.
You're gonna-
That was in 1986.
Yeah.
Let's scroll down.
That right over here.
And pipelines were invented in 1973 when Ken Thompson added it to the version of Unix, the first version of Unix that he invented in 1969, when he was when his wife was having a baby, and he had a month to just sit around and make an operating system.
Nice. I've never used the TR command.
It's the translation.
Translate.
Yeah, translate.
Substitute one character for another person.
Nice. Learn something new today. That's the other fun thing about Linux. You will learn something new literally every day.
Yeah, so tell me about Plan 9. I noticed in your HTOP you had Plan 9.
No.
Okay.
No, I think that's just something built in WSL. I didn't do anything.
Oh, you didn't do that?
No.
Oh, interesting. Oh, okay.
Anything else? Other questions or comments? All right, I'm going to stop screen sharing. Thank y'all very much for having me out. Hope this was informative and stimulating.
Yeah, thanks for everybody for coming, and I appreciate seeing everybody.
Do you want to mention?
Hold on, Jace. Do we have
Oh,
a
wait,
talk?
I'm
for,
sorry.
do we have a talk for next month?
Yeah, next month is V2C by your friend out there, and it's Voice to Command. I think it's a protocol that was created.
Oh, yeah.
I suddenly have forgotten. Your friend.
Caleb.
Yes, Caleb's going to be giving that talk.
Yeah.
And Eric just reminded me that I was supposed to remind everyone here in Greenville about. Yes. Hack Greenville Nights is on the 29th.
And it's basically just sort of think of it as sort of a mega meetup of a bunch of different groups. So
Yeah.
there's going to be a lot of different topics talking about. There's going to be some food and socializing. So
Last met about 60 people. It was
So,
really good. It was really
anyways,
good. Yep. Oh, speaking of which, I actually do have one more thing to mention. The Carolina Code Conference is we have a theme that we're going to continue using for our conference T-shirts every year. We call it the Lyrical Code Challenge, where we pick a song that everybody likes and would recognize, and we translate those song lyrics into actual code. Last year we used "Don't Stop Believing." Today is the last day to vote on the finalists. We've got our top 5 finalists. Right now, Bohemian Rhapsody is in the lead, but if you want to go vote, go to carolinacodes.com, and you can go carolina.codes. I keep saying that. I actually went and bought carolinacodes.com to forward it there just because I keep saying that.
Yeah.
But carolina.codes, and you can hop over there. You can find the post, and you can vote for it. And please, for that, if you've got any companies who might be interested in sponsoring, if you know anybody who might be interested in submitting a talk as a speaker, please let them do that. The call for speakers is open until April 15th.
And the call for speakers has just been opened recently for Southeast Linux Fest as well. So go to that, and that's in Charlotte. There's Ben with the fireworks.
Nice.
So yeah. If there's no questions or discussion, then I think we can adjourn. Thanks,
Thank you very
Ben.
much.
We'll see everybody. Thank you, Barry. Really appreciate it.
Bye. Thank you.
Barry. Wonderful job.
Thank you.
All right. feel like that went pretty well for a presentation I started at